Hello everyone, I'm Arjun Arula from Punjab Engineering College studying in second year in Electronics and Communications Engineering. The topic for my project is Traffic Light Controller. So let us first design the system of the controller. To design the system, I first want you to know some basic terminologies which I have used. Here, M1 refers to the road which moves from left to right in this manner. MT is the main turn from the main road. M2 is this way traffic which goes from right to left and also turns from top to bottom. S is a side turn which merges into the main road. Now let us see the first state. Here in this state, since the M1 traffic is moving easily, hence M1 is green, whereas MT is red because the people flowing in the M1 road can't turn towards MT. Hence MT is red, whereas M2 is green since the people going from right to left can move from right to left and also turn down. S on the other hand is red because the people from the side road can't turn towards the main road. Now this remains green for a certain period of time. Let that time period be TMG. Now let us see what happens after TMG. After TMG, what happens is M1 still remains green. M1 still remains green, so the people flowing in this road have no issues. MT is still red. MT is still red since the people flowing in main road can't turn towards the side road in this configuration. M2 on the other hand is yellow. S does not change its color. Now, after the time Ty for which the M2 has been yellow, let us see what happens in the third state. In the third state, M1 is still green. The people flowing in M1 still have no issue to move towards right. MT on the other hand has also turned toward green since the people in the main road can make a turn towards the side road. Hence MT is also green. M2 is red because the people from the main road can't move from right to left. Hence M2 is red and S on the other hand is also red. Now after a certain period of time TTG for which MT has been green, let us see what happens next. Now in the fourth state M1 and MT both simultaneously become yellow and M2 is still red because the people from the right in the main road from the right cannot move towards left or turn towards the side road. See, the side road is very narrow. So if the people from M1 are turning, then M2 people should not turn so as to avoid accidents. And the side road is still red. Now, after a period of time Ty seconds for which M1 and MT have been yellow, let us see what happens in the next state, that is the fifth state of our system. Now, in the fifth state, now M1 becomes red and MT also becomes red. Now, in this state, M1 is red, so the people from the main road can't travel from left to right. And MT is also red, hence the people in the main road can't travel from right to left as well. Whereas M2 is also red. So M2 is red because the people from main road can't travel from right to left. MT was red because the people can't turn towards the side road. And the S is green. Finally, the people from the side road can turn towards the main road. Now, for a particular time TSG for this S light has been green, let us see what happens next in the next state. M1, MT and M2 still remain red, but S turns yellow for a time period of Ty seconds. Now after this Ty seconds, again we go to the first state and this cycle continues. Now we have come into a position where we can design the state diagram of this particular system. So let us have a look at the state diagram of this system. So for the state diagram, I make this state as S1. So if the time period has not reached till TMG, the system will remain in this state, and if it has been TMG, it will move to state 2. For state 2, we had the time Ty. If the time period has not reached Ty, then the system will remain in T2, otherwise it will jump to S3. Similarly, it goes on. For TTG, if the time period has not reached TTG, it will remain in S3, otherwise it will jump to S4. So similarly, S5 and S6 follow. Now, I also want you to know some more things. For this time, I have set TMG as 7 seconds because the preference should always be given to the main road vehicles since the main road has more traffic. Ty for every traffic light has been 2 seconds. TTG, which was the main road right to left light, has been green for 5 seconds, and the TSG has been green for 3 seconds, which was from side to main. Now let us design the state table. For the state table, what I have done is I have assigned red, yellow, green to M1, M2, T and S, and following this, if for example, if for state 1 TMG has not reached, so M1 here has been 001, which means that it is not red, it is not yellow, but it is green, hence it is 001. So M2 is also 001. MT is 100 because it is red, not yellow and not green. Hence, in this way, I have presented the state table. Now, let us look at the Verilog code. So, for the Verilog code, let me float this and okay. So for the Verilog code, I have taken two inputs clock and reset and the four outputs light M1, S, MT and M2. I have defined the state parameters and a variable count. So here sec7 is actually my TMG, which I had set for a time period of 7 seconds. Ty, I have used Ty as sec2, which is 2 seconds. TTG has been declared as sec5 for 5 seconds and TSG is actually sec3 for 3 seconds. Now let us focus on the code. So for positive edge clock and positive reset, if reset is 1, then we'll begin and set the state to S1 and count to 0. Else we have a switch statements for determining the states. See, I told the way I explained you before the state table. Now let us pay attention to the state table. I said if TMG count has not reached, it will remain in state S1. If the count is less than sec7, which was TMG, the state will remain S1 and will increment the count. After some time, when count will exceed sec7, then the state should jump to S2. Then the else statement would be executed and the state would jump to S2 and we would reinitialize the count to 0. For S2, similarly, we had to use the time period ty. Ty was 2 seconds, which is declared as sec2 in the Verilog code. Now, if the time count has not reached 2 seconds, then it will remain in the state 2. Otherwise, if it has reached, it will jump to S3. Let us see in the code. If the count is not reached S2, the present state will be S2 only and will increment the count. But if it has reached S2, it has reached sec2, that is t by seconds. Now it has to jump to S3. So state becomes S3 and we reinitialize the count to 0. Similarly, for S3, we had used TTG, which was declared as sec5 for 5 seconds. Now, if the count has not reached TTG, it will remain in the state S3 only. And if it has exceeded TTG, that was sec5, 5 seconds, it will jump to state 4. Similarly, for state 4, we have Ty, which was declared as sec2. So if sec2 has not reached, it will remain in S4. If it has exceeded, it will go to S5. For S5, similarly, we have TSG time period. So if it has not exceeded TSG time period, that is sec3, it will remain in S5, otherwise it will jump to S6. Now in X6, if the count is still less than, okay, here is, I have made a mistake, this had to be ty bar. Okay, so if the count is less than ty bar, that was 2 seconds, then it will remain in S6, otherwise it has to go to S1. See, here it is ty bar, okay, because here we waited for ty seconds, right? Okay, so this ends our always block for the states. Now we have the next always block for the outputs. The outputs have been written in the same way what I explained before. So if M1 was green, then it has been assigned 0, 0, 1. I have declared a vector 2 is to 0, 2 down to 0 for every output light, and the output is coded in the same way. Now, okay, let me explain it. Let me explain only for S1. Okay, so everything follows same way. So for M1, we have 3 tick B001. So for M1, we have in the S1, which means that in S1, M1 is green and M2 was red. So if M2 was red in state 1, in state 1, sorry, in state 1, M2 was also green. I'm really sorry. In state 1, M2 was also green. So it has to be 001. It is 001. MT was red. So here T signifies MT. So hence it is 100. It is 100. See, it goes R by G. Every time it goes R by G. And S was red. Hence it is 100. See, if you want to see it in form of colors, see, I said M1 was red 001, M2, sorry, M1 was green 001, M2 was green 001, MT was red 100, and S was red 100. Similarly, I have written for every state. This is all for the Verilog code. Now let us see the test bench. Okay, for test bench, I have declared, see, the inputs had to be declared as reg and the outputs had to be declared as wires. Next, I have instantiated my module traffic light controller and have given the clock. Next, I have initialized a reset for one time period and then have finished the code. I have also simulated this to save the time for explanation. Now let me use the pen so that I can explain it. Okay, so this is for the present state. Here, so from here, see, I declared, okay, okay, yeah, see, the TMG was 7, right? So till 7, it remains in the first state, which was defined as S0. See, uh, defined as S1, which was given as 0. See, I gave S1 parameter as 0. So till now, okay, my laptop is hanging. Till now, it before, if the count S7 has not been reached, it remains in this state. And if it is in this state, let us see what is the outputs. See, M1 is 1. If it is 1, it means that M1 is green, right? It had to be R by G, right? So R is 0, Y is 0, and G is 1. So M1 is green, S is red, MT is red, M2 is green. Let us see again. M1 is green, M2 is green, MT is red, and S is red. Hence, the code works till here. Now, let us see for the next ty time period. For next ty time period, that is from here to here, the state is 1. That was state S2 in our Verilog code. See, I assigned in the parameters, I assigned S2 as 1. Okay. Now it says that M1 is 1. Hence M1 is green, S is red, MT is red, but M2 is yellow. Let us see. Okay, only M2 is yellow, MT is red, S is red, and M1 is green. Hence, the code is correct till here as well. Now, okay, let me delete this and select the pen. So we analyze till here. Now, let us see from here till here. This is the third state. Now, in the third state, let us see what happens. See, M1 is 1. It is 1, it means that it is green, right? S is 4, it means that it is red, right? MT is 1, which means that this is also green, and M2 is 4, it means that it is red. So let us see what happens in the next, what had happened in the next state. See, M1 and MT both were green and M2 and S were red, right? So M1 and MT both are green and M2 and S 4, right? It had to be R by G, remember? So if it is 4, then it means that they are red. Hence our code is correct for this state as well. Now let us verify it for the next ty seconds. That was till 2. Now in this state, M1 is 2, it means that it turns yellow. S is still 4, that it means that it is still red. MT turns 2 means it is yellow. M2 turns is already 4. Let us see what happened in this state. See, so in this state M1 and MT were yellow, M2 and S were red, which is M1 and MT were yellow, S and M2 are yellow, which means that this state is also correct. Next, let us analyze for the fourth state. In this state, let us see what are the colors of our traffic lights. In this case, M1 is 4, which means that M1 is red, S is green, S is green, MT is 4, which means that it is red, and M2 is 4, which means that this is also red. So let us see, okay, I had to select this. Let us see this state. See, M1, MT, M2 all are red, only S is green. Here all are red or have 4 value and only S has the value 1, which means that it is green. This means that this state is also correct. Now let us verify our last state. In our last state, let us see what are the colors. Okay, in our last state, M2, MT and M1 are red and S is also red. S had to be yellow, right? Let me see if I have made a mistake in my code. For the last state, S had to be yellow, right? See, S, okay, okay. I made a mistake, right? A here had to be yellow. Now this will work fine. Okay, so after we'll correct that mistake, everything works fine. So this was all what I wanted to explain you in the video. Thank you for your patience, and I would love to have feedbacks from you.